everyone, welcome to this video. This is a Math 081 video, 3.1 part 2. In this part, we're going to start learning how to solve a formula for a specific variable. So what's going to happen is we're going to have a variable that has, an equation that has all variables in it, no numbers. And we're going to have to figure out how to use the rules of algebra and the concept of inverse operations to isolate the variable, okay? In the textbook, they call it a target variable. If you want to call it that, you can. It's totally up to you. And just realize that since there aren't any numbers, you're not going to get something that looks like, x equals 2 or, y equals 5/2. You're not going to have something that looks like that. It's going to look very different from that because it's just going to be a bunch of different letters. Okay? So let's get started. So down here we have our first example. It says, solve the formula u is equal to mgh for h. So let's just kind of copy this down. U is equal to mgh. Okay? So our target variable, if we're going to use their vocabulary, is g. So we want to isolate g. That's our goal. Okay? But right now, g is not isolated, right? G has an m and an h attached to it. Okay? So here's the thought process that you want to go through whenever you're doing a problem like this. Okay? You ask yourself, how are m and h attached? In other words, if they're sitting right next to the variable without any signs in between, what mathematical operation is being implied here? So hopefully you understand that mgh implies that everything's getting multiplied, right? M times g times h. So the answer is multiplication. So then the next question we ask ourselves is, okay, cool, they're being multiplied. How do we undo multiplication, right? And hopefully you know that the way you undo multiplication is through division, okay? So if I want to get g all by itself, what do I have to do? Well, I have to divide by m, and I also have to divide by h, okay? And that's exactly what we're going to do. We're going to divide both sides, and again, remember, they mentioned it up here in the steps. Whatever is done to one side of the equation has to be done to the other side of the equation. You can think of this, an equation as sort of almost like a scale, right? So if right now the equation is balanced because what's on one side is the same as on the other side here, right? The only way to maintain that balance is to, again, if you add something to one side, add it to the other side. If you subtract it from one side, do it to the other side, and so on and so forth. So back to this equation, if I divide by m and h down here, and also do the same thing on the right-hand side, again, to keep the equation balanced, hopefully you can see that these two m's cancel out. These two h's cancel out. And then on the other side, we literally just have what almost looks like a random collection of letters, but that's okay. So we have u divided by mh equals g, okay? And that's it, okay? So that's what they meant right here when they said you will not get a single number as the answer, right? Clearly we have a collection of variables that are attached through different arithmetic operations, in this case, multiplication and division, and that is our answer. Okay, let's do a few more problems. Okay, it says the formula rate is equal to distance divided by time relates distance, rate, and time. And they want us to solve this equation for t. Okay, so just to kind of emphasize that the idea that everything that we're doing right here is exactly stuff that you've already done in previous sections, only when you were doing it, you did it with numbers and not variables, okay? So over here on the left-hand side, we'll call this an imaginary problem, okay? This is really not the problem we're being asked to solve, but we're going to solve it anyways, okay? So let's pretend that we were given the fact that the time is equal to 2. Okay, if over here on this left-hand side, this imaginary problem, I had to solve for d, what would I do? Well, again, you ask yourself, how is the 2 attached to the d? Well, it's attached through division. how do you undo division? You undo division by the inverse operation, which is multiplication. So if I multiply both sides by 2, sorry guys, then you get 2r equals, and then you cross out the 2's, right? So we have the distance is equal to 2 times r. Okay, we are going to go through and perform the exact same procedure on the right-hand side. The only difference here is that we don't have any numbers, we just have letters. But again, the same procedures, the same process is being used. Okay, so rate is equal to distance over time. Okay, they want us to solve for d. Again, if you want to think about this as your target variable, you can think about it that way. Okay, so we say, okay, well, how is that t attached to the distance? Well, the time is attached to the distance through division. Well, how do we undo division? We undo division by multiplication. That's the only way to undo division that I know about anyways. Okay, so when we do that, what happens to the t's? Well, hopefully you can see they cancel out, which was the whole point in doing that in the first place. So you have time times rate is equal to d. Usually, just as a matter of course or form, we usually write the letters in alphabetical order. So we would have rate times time is equal to distance. But if you had expressed it that way, that would be correct as well. Okay? So hopefully you can see the analogy here between these two problems. We did the exact same procedure. The only difference is on the left-hand side, we had actual numbers, right? And over here on the right-hand side, we just had variables. So believe it or not, all of these problems that we're learning in 3.1, the tools that you need, the process that you need, you've already learned because you already know how to solve multi-step equations, okay? The only thing that we're doing here is we're doing a little switcheroo. We're getting rid of the numbers and we're just putting variables in their place, okay? So let's do a few more problems before we have to end this video. So here we have P is equal to K divided by V. Okay, and we want to solve for the volume. So this is a little bit different here because I can't just divide by K. I mean, I could divide both sides by K, but then I still have this volume, this V on the bottom. So there's several different ways that you could think about doing this. One way that I often think about it is if you think about it as P over 1, then what you can do is you can cross multiply, okay? So we'll say that this is option 1. Okay, so when I cross multiply, I get P times V is equal to K. And then to finish solving for, V, then I would have to divide both sides by P. And so you end up with the volume is equal to K divided by P. I don't know if I think I might have just referred to V as volume. I apologize for that. V may or may not be representing the volume. I'm not sure. Okay, so let's think of another way to solve the same problem here. So we'll call this option 2. All right, so we have P is equal to K divided by V. So another way that I thought of doing this, and you might think of a third way that I didn't think of, you could multiply both sides by V, because again, the problem here is that we really have to rescue V from being in the denominator. If we're going to isolate it, if we're going to get V equals something, then V needs to be in the numerator. Okay, so I could do that. I could have P times V is equal to K, and then again, going back to actually isolating V, then I would have to divide both sides by P, and I would still have the V is equal to K over P. Okay?